Hello to you all, wonderful and awesome Mindsetters, Grade 12 Mindsetters. This is your best show for learning. Of course, it is Learn Extra Live with me, AB, and I'm joined today by Kamilin. I'm going to introduce him shortly because some of you, I know that you know him. It is geography today, and I just need to tell you about the competition that we're having, the awesome competition. I think everyone knows it by now. It is the Learn Extra Going the Distance Together, probably brought to you by Samsung in partnership with Mindset. All you need to do is to download your notes on the link that's going to be on the website, on Facebook, and go to www.mindset.co.za/learn/win, and that's where you could stand a chance of winning an awesome device like this one, a Galaxy Note 10.1. Now we're on leg number 6, which means there are only 3 more devices to give away. We've already given away other devices to lucky mindsetters. Even today, you've seen on the page, we had Victoria Mukhala who came and fetched a Galaxy Tab 10.1, one like this one. So it is a cool device to have. On it, you can also access the Learning Hub. It has an S Pen, which is more like your real pen when you're writing. So many great features. Mindsetters, it is a must-have. If you don't have it, don't worry. Enter for the competition. I'll tell you more, and I might give you the race number. Otherwise, Mr. Kamlin, how are you?
Hi, Abram. Welcome, guys. Welcome to another exciting exam revision session. Today, we've got to get all our ducks in a row. Geography is just a few hours away, and I'm sure today's lesson is going to give you everything you need to get closer to that symbol that you need. Abram, are we ready?
We are ready, and from the page, I've been seeing a lot of mindsetters that are doing geography specifically asking, are we going to have any scope? I think this is why they should watch the show, because this is the only scope that we're giving them.
Great, guys. The scope, you've got to know and be able to understand as much as you can, especially in your theory and map work. So we're going to start off with some questions taken from previous exam papers that is going to help you better understand and how to answer these questions. So let's get straight to it, and we're starting off with climatology, global air circulation. And as you can see, our focus today is as follows, and we're going to work through today all the paper 1 examinations. So if you have any questions on paper 2, please feel free to give them to Abram, but our focus today is going to be paper 1, theory paper, and everything you need to know before you go. So let's go further and look at the questions that we have. If you look at the first one we've got, it's adapted from the February-March 2013 paper, and note the following: global pressure belts and winds. And we've got a diagram that shows you the entire globe as it is, with the arrows showing deflection. Remember, already you should be thinking, when air deflects, it moves across Coriolis force, correct? And this circulation is involving the 3 cells, the Hadley, the Ferrel, and the polar cell. So already in your minds, you should be thinking about these concepts and applying them to the diagram at large. Let's go to the first question and understand it. Name the pressure belt labeled A. When I go to my diagram, immediately A covers this area here. And no, it is not the ITCZ. It is a low pressure belt, because the question says, name the pressure belt labeled A. You could also include an answer like doldrums. Let's check the answer. And the answer is equatorial low pressure belt, or doldrums. That is correct, and that gives you the 2 marks. Remember, when we are asked these kinds of questions, read carefully. It says describe, it says name. In this case, we were asked to identify and label. So in this case, the correct answer for A is your low pressure belt or doldrums. Let's go to the next question. Which major cyclone, low pressure, is driven by the westerly winds? Guys, immediately, major cyclone. You have only studied 2 cyclones in the secondary circulation model, and these are your tropical as well as your mid-latitude cyclones. These are the 2 that you should be focusing on. In this example, driven by the westerly winds. I'm going to give you a chance to answer that before I show you the answer, and the correct answer is mid-latitude cyclone. The mid-latitude cyclone is driven by the westerly winds. Remember, your tropical cyclone driven by the easterly winds. And these are the types of questions you're going to get to apply to this kind of diagram. Let's go to the next question. State the force, that deflects. And these words are the clues that are driving you towards deflection forces. You should already in your mind be thinking of pressure gradient, Coriolis, and geostrophic flow. And when these concepts come together, you apply it to the question. Force, deflection, southern hemisphere. Coriolis force. And let's have a look. Correct. The correct answer is Coriolis force. Remember the law, Ferrel's law. When in the southern hemisphere, the Coriolis force deflects air to the left, and in the northern hemisphere, to the right. Good. I see you following well, and you're applying the concepts to the global air circulation model. Let's move further and look at the next question. What type of pressure is experienced in Area C? Let's look at the diagram. In Area C, immediately that's your 90-degree latitude. Remember, your equator is 0 degrees, your poles are 90 degrees. What type of pressure is experienced at the poles? It can only be either a high pressure or a low pressure. And remember the following, your pole is a high pressure area. So the correct answer there is high pressure. Are we seeing that the movements and planetary wind models are also being applied to the global air circulation model? Key concepts here, guys, to remember is the following. Your equatorial low pressure belt, your polar high pressure belt. And simple questions like this help you better understand the type of pressures experienced at these different latitudes. Let's go to the next question. The high cloud density in Area A is due to convergence or divergence of moist air. Let's go back to the diagram. Note the arrows are converging at this point, A. Are we seeing that? Arrows coming together, convergence. Arrows moving apart from each other, divergence. The question, note the following. The high cloud density in Area A is due to convergence. And that's your correct answer. Note the 2 marks. Let's move on. What I want you to concentrate on, especially with global air circulation, is the 3 cells. And note the following. The movement is localized in each one of those 3 cells. Know which cells are weak, which cells are strong. For example, your Ferrel cell, which is between 30 and 60 degrees, is the weaker cell. Your Hadley cell, between 0 and 30, as well as your polar cell, between 60 and 90, are your high pressure cells and therefore much stronger. Let's look at the next question in climatology. The next one deals with synoptic weather maps. Remember, your synoptic weather maps is a graphic representation of a daily weather forecast. Okay? And when we're dealing with synoptic weather maps bring together and apply all the concepts of climatology. So you have to be able to understand each one of those concepts of mid-latitudes, tropicals, your 3 high-pressure systems on a synoptic map and be able to apply these theoretical concepts into one question. And in this particular question, we've headed it to synoptic weather map, and you've got to be able to understand what's going on in this. Some advice, if you get a synoptic weather map in your exam paper, the first thing that you should do is outline South Africa. That'll give you a perspective of where you are in terms of the synoptic weather map, and it also gives you an even distribution between the east and the west. So let's look at South Africa on this map, and clearly this would help us better see the country in respect to all the formations that are around it. Immediately, I should be able to identify my isobars. There is a low pressure system that is developing on the east coast. Do you see that? That is obviously your tropical cyclone. What you can't see, I'm sure it's visible now, is tropical cyclone Funzo. And note it's on the east coast of South Africa. So let's just undo that. Okay, there we are. Let's look at the next question. Identify the pressure systems X and Y on the synoptic weather map as either a high pressure or a low pressure system. Let's look at the synoptic map. Locate X. Immediately we should see that X is located in this portion. There's South Africa, and what you should be seeing is it's on the west. So what does that mean? That means that this particular formation is your South Atlantic High, and therefore the correct answer is for X, South Atlantic High. Let's do Y before we reveal the answers. And Y, you'll note Y is located here, and that low pressure system there, and obviously the clues are given in this answer. Let's go back to the diagram and question. The answer is X is your high pressure system and Y is your low pressure system. Let's go to the next question. Give evidence to support the statement that this is a summer map. Now guys, I want you to understand, when you're trying to identify the season on the map, and generally the two seasons that are coming into question is your summer and your winter maps. This is obviously a summer map, and the first thing in your mind should be that the tropical cyclone is present. Also look for temperatures. Remember, in a summer map, your average air temperatures are above 25 degrees Celsius. And these are the two types of answers you'd be looking for in a summer map. In a winter map, remember your average air temperatures are below 20 degrees Celsius. Let's look at some of the possible answers that were given. In this case, tropical cyclone Funzo, because your tropical cyclone can only occur during the summer season in a year. The next one, high temperatures. Let's add the word air temperatures to that. South Atlantic High and South Indian High lie south, further away from the land. Remember, your high pressure systems are seasonal migrators. They migrate south and they migrate north. Let's look at that on a synoptic weather map. The synoptic weather map that we have shows us our South Atlantic High and our South Indian High. Note the position. They occupy a more southerly position in summer. In winter, on your synoptic map, they would be migrating northwards. Let's go on to the next one. And that further, for the synoptic weather map, is the next question. Identify the depression. Now guys, if you don't know what a depression is, it's an alternative term for a low pressure system. A tropical cyclone and a mid-latitude cyclone can also be called a low pressure or a depression. A depression describes any system that is occupying a low pressure position. That is affecting the weather of Limpopo and Mpumalanga. Immediately, you should know these two provinces occupy a more easterly position on the map along the east coast of South Africa. So, there's our synoptic weather map. Here's South Africa again. And there's your low pressure system. How do we know that it's a low pressure system? It's given the name Funzo. It's a tropical cyclone. Do you see that? So the correct answer in this particular example, tropical cyclone Funzo. And that would afford you the 2 marks. Let's go on to the next question. How many tropical cyclones occurred before Funzo in this area? Give a reason for your answer. Immediately, remember the following. All tropical cyclones are named alphabetically. And if tropical cyclones are named alphabetically, Funzo, which has occurred on the east coast, A, B, C, D, E, F, is the 6th tropical cyclone. This particular question wants to know how many have occurred before Funzo. So obviously your answer here would be 5, and in this case, 5. Give a reason for your answer, named alphabetically. And you've scored the full 4 marks for an easy question. Guys, remember, you've got to be able to understand the naming of tropical cyclones as opposed to the description of tropical cyclones. These are the types of questions that you would get in this particular area. What I want to go further with is the following. When you're looking at tropical cyclones, remember your stages of formation, your characteristics, as well as the different requirements for the growth of a tropical cyclone. How are we doing, Abram?
We're doing so well. We have some questions of which I think we should take them after the break.
Good. Are we going to a break now?
Yes, we should.
Great. Come back, guys.
Right, Mindsetters, before we go to that break, remember you can enter the competition on www.mindset.co.za/learn/win, and you could win an awesome device, probably brought to you by Samsung. Otherwise, get all your friends to like our Facebook page, because now we're running a campaign whereby we need to reach about 100,000 likes. We want 61, Mindsetters. I know you can do this. Let's help other Mindsetters, because we are going the distance together. See you after this. Welcome back, Mindsetters. Now, if you just joined us now, you've missed a bit, but you can still ask us your questions, because we are doing some exam questions for geography. Hoping that you are grasping everything, Mindsetters. But looking at the page, we have some questions for you, Kamil.
Great. Let's hear them, Abram.
All right. The first one is from Rifle. Actually, Rifle is done writing, so I think he's just asking for other Mindsetters.
Okay.
I hope you wrote well. He's saying, what is the difference between the coastal low and the cyclone?
Okay, rifle. Hi. Well, remember the following. A coastal low is a low pressure system that occurs along the coastline. A cyclone can also be called a low pressure system. Whenever we refer to a cyclone, we are referring to low pressure systems. Anticyclone, high pressure systems. Let me show you an example, Riffle, of a low pressure system or a coastal low. In this particular map, you'll note that the low pressure system is over the land. When a low pressure system is over the land, we call it a thermal low or a continental low. If a low pressure system occurred along the coastline, this would be, let's get back to that page, this would be a coastal low. I hope that is able to understand, Riffle, what is going on there. Remember, your cyclone is referring to a low pressure system. Your coastal low refers to a low pressure system in terms of its position along the coastline. How's that, Abram?
Okay, good
Okay,
one.
the next one.
Here's another one based on question 2.2.
2.2, let's go back to 2.2. Yes.
Troy is saying, for 2.2, would I be wrong if I said there's a low pressure over the interior?
That is excellent, because Troy is going beyond the synoptic weather map and he's applying his knowledge. Troy, remember, and well done. Your low pressure system is dominant over the interior. Your low pressure system, which is your continental low, is dominant over the interior in summer. And during your winter months, your Kalahari high, which is the high pressure system, covers the map of South Africa. So excellent answer. Let's go back and check that one. And remember, here, thermal heat low inland. I would describe it as follows. Low pressure system dominant over the interior during summer. Well done, Troy. You're taking it further, and I know you're going to get the result that you deserve. Abram, what's the next one?
Michelle saying, why is it windless and cloud-free in the center of the tropical cyclone?
Okay, Michelle, welcome, and I'm excited about your question. Why? Because you're referring to the dynamics of a tropical cyclone. The center of the tropical cyclone is called the eye. Remember, the eye is associated with cold, clear, cloudless conditions, descending air. So therefore, when we're describing the eye, that is what we refer to, the type of weather conditions experienced in the eye. Remember, let's go back to your synoptic weather map. When you refer to your synoptic weather map, the center of this map, the center of this low pressure system is called the eye. It is associated with calm, clear, cloudless conditions. Around the eye, in this area here of your isobars, is your torrential rainfall as well as your gale force winds. How are we doing, Abram?
We're doing well. Let's just take a last one for now.
Oh, okay,
a question that all Mindsetters are struggling with, because I've noticed that on the page. Sikidane says, when we are writing a short essay question, are we allowed to write headings and subheadings?
That depends on the question. Excellent, because types of paragraphing questions are going to require you to write in paragraphs. However, what you've got to do is, as we're going to use an example later on in the show, is be able to interpret the question. Does it require you to refer to two aspects or one? If, for example, you are getting a question in the climate section of the syllabus, and you are asked, compare the environmental as well as social impacts of a tropical cyclone, then I would agree with you, you can use subheadings, but your answers must be in a paragraph format. So what I would do is, I'd write the heading, impacts on the environment, and write my paragraph, impacts on industries, write my paragraph. This is how you can formulate, and what it does for you is it shows the examiners that you know what you're talking about, that you understand that there are 2 or 3 parts. What I'm suggesting, guys, is when you're reading the question for paragraph writing, and remember it's a 6 times 2 equals 12. In your paragraphs, you've got to have 6 solid points that are going to best describe both or one idea that is questioned. And generally what we find in is this kind of question, you get a comparison question, which means, for example, identify in a paragraph the impacts, both natural as well as environmental, on the area of South Africa, especially when a tropical cyclone is nearby. Are you doing fine, Abraham?
Yes, sir.
Okay, guys, I'm happy you are asking these questions, and they hopefully will get you to the marks that you deserve. Let's move on to the next question and look at what we've got for you. It's also on synoptic weather maps, and still continuing with the concept of tropical cyclones and applying it to a synoptic weather map. The next question, in which ocean did Funzo originate? And what you should remember is that all over the world, whether it's typhoon, and you'll note recently, not just a few days ago, Typhoon Haiyan, which is in Southeast Asia, which caused millions of rands of destruction in that particular area. When it's in the northeastern seaboard of the United States, it's called a hurricane. In South Africa, we call it tropical cyclones. And in this case, all the oceans that it originates in is warm oceans, this area here. And the Indian Ocean provides the warmth, moisture. The moisture levels are higher, and therefore the tropical cyclone is able to formulate. So let's get that answer there. Oops. Yeah. Okay, the correct answer there was the Indian Ocean. I'm going to skip that one and move on to the next one. The economic impact of floods associated with tropical cyclones is great. Immediately we can see we're moving towards a paragraph type question. And in this case, write a paragraph, approximately 12 lines. Now, in the, when you see these kinds of questions, what you've got to understand is when they're saying 12 lines, the examiners are referring to you combining those different sections in a format that speaks to 12 lines and not in a bullet form. Your sentences have to be continuous. So, explaining some of the economic effects of flooding on Mpumalanga and Limpopo. This kind of paragraph question is referring to one specific point, and in this example, economic impacts. Let's look at the possible answers for this. And in this case, we've got economic effects of flooding on Mpumalanga. And as you can see, economics does not deal with the natural environment. It deals with the social environment. And therefore, possible answers could be damage to property. Note, for the memorandum purposes, we have put it in bullet forms, which you should be taking down now in order to formulate them into paragraphs. Loss of stock, destruction of agricultural land as well as crops. Moving further, food shortages. Food has to be imported. All these aspects of food security, as well as food shortages, need to be understood in the context of economic destruction. And these kinds of things bear fruit to losses of life, destruction of infrastructure, transport, as well as communication networks. As we've seen last week, if you were watching the news carefully, Typhoon Haiyan, the impact, and was considered one of the worst typhoons in the Southeast Asia area. But what is important is you've got to look at the destruction that it caused, especially in terms of infrastructure, transportation networks, silting of dams, as well as insurance companies suffer heavy losses due to the large amount of money paid out. So generally speaking, these kinds of natural disasters have a negative impact on the economy. And you can go on and write as many sentences, but the examiners limit you to 12 lines. If you have an idea and you want to add more, there is no crime. Guys, write as much as you can, but not too much, in order to secure you getting full marks for this section. How's it going there, Abram?
So well.
Are the questions
So
coming
many questions,
in?
yes.
Good. Let's go on to the next one. And in this case, we're moving on to the next section, which is urban heat islands. Now, your urban heat islands is an application section again of climatology. And here we're looking at the urban landscape in terms of air temperature distributions. And these are kinds of questions you're going to get in an examination in order for you to understand how is air temperature distributed across the urban landscape. So, let's look at the first question. What is an urban heat island? Now, guys, get your pens ready because I want you to take this down. An area of higher temperatures over the city surrounded by lower rural temperatures. This is a concept that describes urban heat island. Remember the following. When you get a group of words together, you are referring to a concept. Your conceptual understanding needs to include the following: higher temperatures over the city, or you can replace that word with urban. Surrounded by lower rural temperatures. And in this example, I'm not going to refer to the diagram immediately because this urban heat island is located in this particular area here. So let's go further to the next question. State 2 factors that cause urban heat islands. Now, when you're looking at the urban landscape, you're looking at an aesthetic environment, a built environment, a man-made environment. And man-made means the types of material that is used to construct a city, like, for example, concrete, tar, glass. All these materials absorb heat. During the day, as the temperatures are increasing, the absorption of heat is much higher. What happens is the urban city center becomes a hive of high temperature, higher than the rural areas where there is no man-made structures or much less, and therefore it's allowing to release that heat. So that stored heat energy creates the urban heat island. Other factors that can contribute to the urban heat island could be the carbon monoxide fumes from cars. Because of the high concentration of transport in and around the urban area, you have a high concentration of carbon monoxide gases. These gases are released from cars, and they contribute even higher to the microscopic nuclei that increases the temperature. Let's look at the answer. And the possible answers there could be high building density, urban activities, artificial surfaces. We've spoken about that. The geometric shape of surfaces. What is indicative of the urban landscape is that the high-rise buildings trap this urban heat. With its materials, it's going to increase in temperature and cause much more heat in the city. Artificial heating, like air conditioners. Lack of vegetation, higher populations, as well as effective drainage systems. Guys, there's many answers that you can use in order to understand this particular and answer this particular question. But remember the following. The most important aspect here is this artificial, aesthetic, man-made environment that is going to contribute to the higher temperatures in the urban landscape. Let's look at the next question. Differentiate between the shape of the heat island during the day and the shape of the heat island at night. Two large comparisons, day and night. What you should remember is the following. During the day, higher temperatures, rising or uplifting air. Night, lower temperatures, descending air. What does this mean for the city center like Johannesburg, Cape Town, Durban? What happens to the city during the day and night in terms of air temperature? Let's go to our diagram. And in our diagram, we should see the following. There's our diagram. Note the extent to which the dome or urban heat dome is expanded. during the day, the dome is much larger. Its extent is way above the city. The concentration of heat expands. And because of this expansion, it creates a larger dome over the city. Why? Because the air is rising, but because of the heat island, it remains trapped within this specific area. Let's go. There we are. Let's go to the next one. Let's look at the nighttime conditions. What's happening at night? Temperatures, air temperatures are decreasing. That means there's a strong descendance of air. And this air descends, and the dome or urban heat islands is restricted to the city. That's why the city generally at night is higher in temperature. But at night, the dome is much smaller, much more constricted, as opposed to during the day, where the dome is much larger and has a much higher vertical extent. Let's go back to the question and look at the possible answer. During the day, extends high above the city. At night, concentrated close over the city. Guys, these concepts are simple. All it requires you to do is to look at the diagram and be able to analyze what is going on. And if you've got the words to best describe it, because geography is about descriptions, how we look at things, how we understand it, and how we are able to write them down. Let's go on to the next question. Explain why urban areas have more clouds than rural areas. Guys, urban areas, more clouds, higher temperatures, you're getting it. Obviously, where there's higher air temperatures, there is more upliftment of air. Where there's more upliftment of air, higher density and cloud concentration. Let's look at the possible answer here. Higher level of pollution from cars and factories produce more condensation nuclei. Exactly. So, what's going to happen? All that pollution that has been collecting over the city center now starts rising. And it rises as hygroscopic nuclei, microscopic nuclei, and carbon monoxide gases, which all contribute to this high heat rising above the city center, and therefore producing much more cloud cover. And these are the factors that you should consider. Higher pollution as well as more condensation nuclei. To describe condensation nuclei to you, it is a nuclei of the pollutants around the city. And what happens is this microscopic organisms that exist in the city center start rising because of the heat. And they attach themselves as they rise to other air molecules and form those clouds. Let's go to the next question. Write a paragraph, approximately 12 lines, to discuss the impact of heat islands on people. Again, a paragraph question. Note the following. The concept is one concept. So those of you who are concerned, can we write in subheadings? In this particular one, you're not writing in subheadings. It's one paragraph filled with all your ideas of, in this example, heat islands and its effect on people. Let's look at some of the possible answers here. Smog and fog reduces visibility. Clearly, during the winter mornings, especially the heat island, it contributes to high levels of fog and smog. Why? Because during the night, the descending air is trapping those pollutants in and around the city center. Increase in the incidence of car accidents among motorists. With the reduced visibility, especially in the city center, the probability of higher accident rates increases, and that is one of the impacts. Heat stress may result in heart ailments. A lot of respiratory problems can result when people are breathing in that polluted air, and this can contribute to low levels of health, especially to people living in the city center. Let's go to the next one. More deaths amongst people living in cities. The irritation of eyes. It has been proven that those people living in the city centers are prone to see more opticians, and therefore the concentration of opticians in the city center is much higher. Now we know that because of the high concentrated pollution levels, this is increasing the amount of people who are affected with sight. The skin disorders, again, more health and respiratory as well as dermatological problems. The quality of life is lowered, and if we move further, people suffer from respiratory diseases such as asthma, again, medical conditions, and of course, high medical costs. And these are contributing to the lifestyles of people living in the city center being depleted. How are we doing, Abraham?
We're doing so well, and on that note, I think we should take some break.
I think we need a break, yes.
Yeah, we really need one. Otherwise, mindsetters know that no one could ever exist as an island. So you need some help. Help other mindsetters on the page. Join our group. We have an online group for all the grade 12s, matriculants. If you are doing geography, of course you are, because you're watching this show, join a group which is called the Mindset Geography. Look for that page on Facebook and then join it, because we have other mindsetters that are there to help you as you are helping other mindsetters. See you after the break. Welcome back, Mindsetters, for the competition. Remember, we're going to be having a draw later on today for a lucky winner who win a Galaxy Note 10.1. It's such an awesome device with great features. The race number is on the page, so look for it. It's somewhere there. Kamlen, let's take some questions.
Yes, let's take some questions from those Mindsetters.
Right. Here's a question from Silelo. Finally, Urban Heat Island. I need help here. How does pollution contribute to Urban Heat Island?
The name again?
Silelo.
Hi, Silelo.
Or you can call him Brilliant.
Brilliant.
Yeah.
And I'm going to give you a brilliant answer for that. So here we are. Pollution, urban heat island. What I need you to understand is this is a physical concept. It deals with chemistry. So if you've got a physical science background, it's going to help you. But let's dilute it to the simplest form in terms of explanation. Any pollution in the city has what we call a molecule. Pollution molecules. As soon as gas is emitted from the exhaust pipes of a car, which we call carbon monoxide. Remember, it's made up of carbon as well as oxygen. And when they combine, they become a carbon monoxide gas, a CO3, CO4, dependent on the chemical composition. Now, what's going to happen? This particular gas is now having latent heat or stored energy. As soon as it leaves the exhaust, it comes out as fumes and then is emitted or released into the atmosphere. But because it's heated, it has a tendency to rise. And when it rises, it starts losing that heat energy. And when it loses that heat energy, condensation nuclei, that means with the reduction in temperature, you're going to have little air molecules combining on this particular element and becomes a pollution air molecule. So what do we say here, guys? We are saying that this is a physical concept of the combination of different chemicals as well as elements in the atmosphere. So when carbon monoxide gas is released into the atmosphere from exhaust pipes in cars, what's going to happen? These molecules are going to rise up into the atmosphere. Why? Because they are heated air molecules, and heated air molecules have a tendency to rise. But when they rise, they start losing that latent energy, that heat energy. And then what happens is that particular air molecules starts grouping around condensation nuclei. Remember, condensation you've learnt in grade 10. It is a temperature or air temperature where clouds are being formed. So these air molecules, pollution molecules, reach a particular point in the atmosphere. And when they reach that height, they form clouds. But what's unique about these clouds is that they concentrated with acid. And these kinds of molecules are destructive in especially the city center. How's that, Abram? Brilliant. I hope you understand that one. We're going to move on to the next question and the next section. So let's see what we've got in the next section. In this particular one, we're still staying with climatology, but we're focusing on here, particularly the movement of the ITCZ. Refer to the sketch, figure 4. And please note, this is again taken from the February-March 2013. We're looking at the position of the ITCZ, and a specific answer here, guys. January, July. It's telling you that we're referring to two different seasons. And in our case, January is our summer month, and July is our winter month. So when we refer to these months, immediately the concept should be that you must understand that those months are given for you to release your understanding of which particular season is being referred to. And let's look at it. What's happening here? Look at your ITCZ. Look at its shape, especially during summer. Look at your ITCZ, especially during winter. What you should be deducing is the following. In summer, the ITCZ moves further south, but in winter, the ITCZ moves further north. What are you thinking about? The movement of the earth, as well as the positioning of the sun and its concentration of insolation on the earth's surface. Let's look at the questions. ITCZ is the abbreviation for what? I'm going to give you a second. Answer that question. Yes, no, correct. Intertropical convergence zone. And if you had that, great, guys. That means you're studying and you know what's going on. This particular diagram, however, is not as from your global air circulation model. It's showing you a vertical extent of the map of Africa and now trying to elicit from you the concept of the movement of the ITCZ. So first question, intertropical convergence zone. Let's go to the next one. Explain the meaning of ITCZ. Note the change in questions. Now that you've been able to identify what does it mean, let's look at this particular answer, and I want you to write this down. An area of low pressure that forms where warm tropical easterlies from the north and south meet. You should be knowing the following. Your 30-degree latitudes, your subtropical high pressure belt releases that heat energy towards the equator. Let's go back to the diagram. And when we look at the diagram, you should note that this is your 0-degree latitude. This is about your 23-degree latitude. And what's happening here, guys? All that subtropical air converges onto the equator. But in this case, the positioning is much different. And here, that convergence is stronger. Here, it is weaker. And simply put, this is how we best describe the ITCZ. It is a convergence of warm subtropical air from 30-degree latitudes to the 0-degree latitude, the equator. And in this particular example, I want you to write this particular definition down. An area of low pressure that forms where warm tropical easterlies from the north and south meet. Look at the word, intertropical convergence zone. Let's look at the next question. State an account, give a reason. I want you to note we are giving you an idea of how to expand your knowledge in terms of the types of questions you're going to get. State an account, give a reason for the position of the ITCZ in July. And I've cheated and I've given you the answer already. And in this case, north of the equator, winter, or migration of the sun. Let's look at that on the diagram in terms of the position of the ITCZ in July. And in terms of the position in July, what you should note is it's north of the equator. Okay? And there's it here again. And what has happened is, because of the tilt or inclination of the Earth, the position of the Earth during winter forces the ITCZ to move northwards, north of the equator. Let's go on and look at the next question. Name any one weather condition associated with the ITCZ. Now, guys, I'm going to give you a chance to answer this quickly. Think about it. When is the ITCZ associated? 0-degree latitude, equator. It is a low pressure zone. As we've done in question 1, you will remember we described this area as the doldrums or a low pressure area. What happens in a low pressure area? Air is uplifting or rising or ascending, hence cloud formation. But what happens at the equator? High concentration of heat, rapid upliftment of air, higher rainfall. Instead of saying higher rainfall, what do we say? We say torrential rainfall. That best describes the heavy rainfall. Look around you, especially now. When it's out there raining heavy, tell your parents, Mom, Dad, this is torrential rainfall, because it best describes that heavy rainfall with especially hailstones. So I want you to look at the possible answers that we could have got here. High temperatures, exactly, directly over land. Low pressure, warm air rises, converging. High rainfall, guys, as the winds converge, moist air is forced upwards. So what's happening around the equator? Air is converging, the warm, moist air. And when air converges, it is forced to uplift and form clouds. With more rapid upliftment, more clouds are being formed. And what's happening? Heavier rainfall, much more hailstones, as well as thunderstorms, isolated thunder showers, especially along the equator. That's why, especially along the equator, areas of Central Africa, areas of Brazil, especially the Amazon, where there is a high concentration of heat, you have endless rainfall and endless summer seasons. That is why, if you look at your globes, you'll see that this particular area is much greener. And as you move from the equator, the amount and nature of rainfall decreases. How are we doing, Abraham?
So far, so good.
Good. Let's go on, guys. Explain the unusual shape of the ITCZ over Africa in January. Let's go back to that shape of the ITCZ, especially in January. And it's almost as an S-shaped. And note, in this particular area, there is a stronger convergence coming from the south. And in this particular area, a stronger convergence coming from the north, giving the ITCZ an S shape. Let's look at the possible answers that you would get in this particular section for this type of question. The difference in heating of land as well as water masses. You clearly saw the air coming from the Atlantic as opposed to the air coming from North Africa, and that's creating the shape. Follows the continent outline as land is warmer. As you've learnt, the land is able to store that heat energy, whereas the oceans are much more transparent. Because it's a transparent, what happens is the heat energy penetrates through the transparency of that ocean, whereas the land is able to store that heat energy for longer periods. Let's go along the west coast. Ocean is cold. I just want to go back to that diagram and show you what we're talking about here. Note, there's your ocean. There's your Benguela current. What is this? A cold ocean. So therefore, there is a higher level of easterly convergence. Here, most of the air is coming from North Africa, countries like Egypt. And what's happening? The stronger convergence is in this particular direction. Guys, this is the ITCZ. It is a development of global air circulation and the global air circulation model. Let's move on to the next question. And that's it. And now we move on to question 5. And guys, for question 5, we're now moving on to your geomorphology. What is geomorphology? Geomorphology is the study of the changes in shape and form of the Earth's surface. Yes, and what do we have to know here? Geomorphology constitutes the second part of section A. So after getting your climatology right, you've got to balance it with enough geomorphology, especially with geomorphology. And here's your application type questions. It brings together the concepts of all geomorphology onto a particular diagram. So when you get your papers tomorrow, I want you to start with your addendum or annexure, your diagram sheet. Start looking at those diagrams and deciding, okay, these are the concepts that are bringing together, like I'm going to do for you now, where we look at the diagram and analyze it before going to any of the questions. So let's look at it. This particular question, settlements in a river valley in the southern hemisphere. And note, there are reasons, hints and tips why southern hemisphere. I should be thinking, they're testing me on the north-facing as well as south-facing slopes. Possibility. Let's look at the diagram. We've got suburb A, we've got B. We've got arrows going upslope. We've got a settlement in this valley. And note, We've also got a floodplain as well as a river system moving through this valley. And in this case, guys, you've got to understand that this is an application type questions, bringing together all different knowledges in geomorphology to apply to this particular diagram. Let's look at the type of questions. Question 5.1, explain the term microclimate. I'm going to give you a sec to answer that. Micro meaning small, climate, weather, weather over a smaller area. That's how you've got to answer your geography. Take each word, break it up, understand. Micro means small, climate, weather, area, small, good. Once you bring these things together, you can understand that the climate over a smaller area is your microclimate. Let's look at your possible answer. Climate over a small area, local climate. Another best way to describe the microclimate is a local climate. This is an alternative concept that can be used in place of microclimates. Let's go to the next question. State one human activity that would have altered the microclimate of the valley. Let's go back to the diagram. There is a clue. Note the industries and how is it located. Can you see that particular area there? Emitting gases like smoke and so on. So what does that mean? How does it alter? It alters the microclimate because it's contributing to pollution levels in and around this area. So my possible answer would be the industries. Let's look at the answer given. Correct, industries, pollution, as well as urban development. And these are the factors that are contributing to the high levels of pollution, changing the microclimate. How are we doing, Abraham?
So far, so good. Some questions, but I'm enjoying the vibe on the page. I think we should take a break on that note.
I think we should take a break. Stay here, guys.
I really need to say this, mindsetters, don't panic. I'm seeing a lot of you are panicking on the page. Don't panic. Just know that we're here to help you through. Put those questions on the page and then let other mindsetters help you, because we know that we cannot do anything on our own. We need one another. Otherwise, keep them coming. We'll see you after the break. Welcome back, mindsetters. Now looking at on the questions on the page, which is on facebook.com/learnextra. Here are some questions that we have come in.
Great, Abraham. Shoot.
First one from Taylor. On question 4.4, all right, let's start with this one, Boitoko, because it's asking about 4.3. Can you please explain further more on question 4.3 about the position of the ITCZ?
Great. I'm going to go back to you, Boitoko. Let's look at what the question 4.3, Abraham. Yes. State an account and for the position of the ITCZ. Now look at this. I'm going to erase some of this so that I can give it to you again. Guys, I want you to concentrate here on the following. Note. Right, and we're there. The ITCZ is your intertropical convergence zone. It is not a static zone located within the equator, but it is dependent on the nature and amount of heat coming from the tropics. Remember, it's dependent on tropical air for its formation. And what happens during January is the following. There is a higher concentration of air converging at this point. And there's a stronger convergence of air coming in from the north. This normally reshapes, correct, the ITCZ. When? In January. Why? In summer months, because of the higher concentration of heat over the ocean surface. What happens is the land absorbs more heat, and therefore this changes the shape. Look at the shape during winter. What is happening during winter? Now the Earth is tilted towards the northern hemisphere. The southern hemisphere is experiencing winter. All your systems migrate northwards. Remember, we spoke earlier, your South Atlantic, your Kalahari, and your South Indian High, the three high pressure systems, don't occupy a southerly position, but they migrate northwards during winter. As they migrate, so too does your ITCZ. And your ITCZ occupies a more northerly position, especially during winter. But in summer, it is concentrated both in the northern as well as southern hemisphere. How's that, Abram?
Very
Let's go
good.
to the next question.
Right, next question from Taylor on question 4.4. Would I be wrong in saying that at the ITCZ that there is a little or no wind as the weather condition?
Would you be wrong in saying little or no wind?
Yes.
Correct. Remember, what is indicative of the ITCZ and this low pressure belt is the Coriolis force. And what you should have learned at school is that there's no Coriolis force over the equator, especially because air is converging and uplifting. As you move away from the equator, what happens? Good. The amount of Coriolis force increases. The deflection of air increases. So what are we saying, guys? At the equator, there is only rapid upliftment of air. In terms of wind directions, it's minimal. But as you move away from the equator, what happens? The amount of deflection increases. Therefore, you're going to have more wind. I want you to take note of the following. Where does the Earth spin the fastest? Great question. At the equator. Why? Because the circumference of the Earth is greatest at the equator. And therefore, remember, all points on the Earth's surface are taking 24-hour periods. However, because of the equator having the largest circumference, what's going to happen? The speed at the equator is much greater. Therefore, little deflection. As you move away from the equator, let's go back to this diagram. As you move away from the equator towards the 10, 20, 30, 90 degree latitudes, the amount of deflection increases because the Earth is supposedly spinning much slower. But it's simply because that if the circumference of the Earth is being reduced. So why is there little or no wind patterns at the equator? Because it's spinning much faster and the air is uplifting much faster. But as we move away from the equator, what's going to happen? The amount of deflection of air increases, and therefore, when there's deflection of air, you're going to have more wind. How's that, Abraham?
Very good.
I hope Taylor understands that one. Let's go on.
Let's just take a last one from now.
Yeah.
What is the difference between superimposed rivers and antecedent rivers?
Antecedent rivers, Abraham. And who's the question from?
Sikitane.
Sikitane, good question. We haven't come to that section, but I want to answer that quickly for you because there's many guys out there who were asking me, what is the difference between an antecedent and a superimposed stream? Take the words superimposed. A river or a stream that maintains its course even after erosion. Superimposed, erosion. Write those words down now, guys. When you see superimposed, it's associated with erosion. And when you see antecedent streams, those streams or rivers that maintain their course even after the upliftment of land. Antecedent, upliftment. Superimposed, erosion. I want you to associate these words. Remember that in terms of these kinds of questions, you're going to be asked to compare and know the differences between the two. So I'm going to say that one more time. Antecedent, upliftment. Superimposed, erosion. I think that's great, Abram. Can we move on?
Yes, sir.
Great. I hope you're enjoying the show, guys, and I hope you're gathering as much as you can before tomorrow. Let's go on. And we've completed that question, and let's look at question 5 if there's anything outstanding. And we've gone on. Here we are. Question 5.3, guys. Give a reason why the suburb labeled A was built along the north-facing slope. And as I suspected, remember they said to us in this question, southern hemisphere. Why was it built in the north-facing slope? Remember when you look at those especially high-income residential suburbs, those houses that were built with glass, especially on the mountaintops, how are they facing? They face towards the sun. In the southern hemisphere, most of these houses are built on the north-facing slope. Let's go back to the diagram so that you can understand. And if we look at the diagram, look at that. Are you picking up these little hints and tips? That is pointing to north. That is your correct compass. It is telling you that We are in the southern hemisphere, and this direction is north. So that means that when the sun or insolation is reaching the Earth's surface, it is shining on the north-facing slope. This is the north-facing slope in the southern hemisphere. Look, there's a suburb built there. But there's no suburbs built on this slope. What does that mean? In the southern hemisphere, the north-facing slopes receive more insolation. What does this simply mean? In winter, this particular suburb would receive more heat. Therefore, the suburb is building using materials like glass, because the air temperature and insulation is able to penetrate and keep these houses warmer for longer periods. Let's go on and look at the answer for this particular question. And what is the reason? We'll receive the direct rays of the sun. It'll be warmer in winter. Remember, warmer in winter. Why? North-facing slopes receive more sunlight. Next one, there will be more light in the house, which will reduce electricity consumption. Are we clear, guys? Are we understanding that in the southern hemisphere, the north-facing slopes receive more sunlight? The south-facing slopes receive less sunlight. Let's go on. Name and explain the origin of wind labeled B. Ha. Now we're talking to the movement of air in a river valley. And there's only two. No, there's many more. But when we're talking about the movement of air, upslope and downslope, we are talking about you? No, you've got it right. Correct. Katabatic and anabatic winds. Katabatic and anabatic winds are those winds that move either upslope or downslope. Let's look at our diagram and look at label B. And if I look at label B, here it is. It is an upslope wind. When do winds move up the slope? What are they called? Winds can only move up the slope during the day, and therefore they are called anabatic. When these winds move downslope, they are called katabatic winds or night winds. Upslope winds, anabatic; downslope winds, katabatic. Remember that, guys. This is simple concepts which you must just remember to ensure that you make these associations. Upslope winds, anabatic; downslope winds, katabatic winds. Let's look at our possible answer. And there we are. Anabatic winds, upslope winds. Have you got that? Commit that to memory, because the possibility is that you're going to be tested on this section, and it's marks for you to get as easy as that. They originate in valleys during the day, where valley slopes are warm. The warm air in contact with the slopes rises. And what's happening at night? The cold air in contact with the slope sinks, resulting in katabatic winds. You are understanding this, guys, and you are getting it right. How are you doing, Abram?
Doing so well.
Are the questions coming in?
Yeah.
Great. Let's move on.
And I think on that note, let's just take a quick ad break, because the mindsetters are having so many questions, and I'd like to throw them to you.
Okay, Abram, you can have your break.
Right, mindsetters, having said that, we'll take a quick commercial break. We'll see you after it. Welcome back, mindsetters. A big shout out to Andy Swa Mtatana, who's saying, I'm loving this show. It's doing wonders for me. A big shout out also to Lucky Protex, who said, just say a shout out for me. So a big shout out to you. We have some questions.
Great, Abram. Let's hit those questions. Guys, I want you to pay attention, because Abram's got some beautiful questions for us. Abram, shoot.
Right, first one from Brilliant. But firstly, here's a comment from Brilliant. What a year it was. Enjoyed a bit of every bit of your live shows, guys. You kind of spoiled me a little. Next year, we're going to miss you. I just can't wait to meet the exam tomorrow. And all the best to everyone. Tons of thanks to Mindset Team. Thank you so much to you, Brilliant. Really appreciate. And your question, is the shape of the Earth a circle, or is it round?
Brilliant. Thank you for those wonderful comments, and I'm glad you're enjoying it, like thousands of other matriculants across the country. Think about this. The Earth is not a circle, but we say it is geoid in shape. It is not a perfect circle, it is geoid in shape. Because of its shape, therefore, the movement of these different weather systems are influenced. A circle is a perfectly round figure. However, the Earth is not perfectly round. we say it is geoid because it bulges at the center, and at the top it is flat. And because of this and its tilt, and I'm going to get a globe the next time I see you guys to show you this, that because of the tilt, the air masses as well as the weather systems are migrating both north and south. Brilliant, thanks for the question, and I hope you've understood that. Remember, it's not a circle, it is geoid in shape, G-E-O-I-D. Next question, Abram.
As Brilliant is ready for the exam tomorrow, as Mine said, we just want to say she's ready to kill the exam, but you should remember also tomorrow between 11 o'clock, as to all the other mentors, from 11 o'clock tomorrow to 1 o'clock, we'll be doing a special show for you, a special revision for paper 2. So I know that you're ready for paper 1 now. We're going to be focusing on paper 2 tomorrow. Make sure you watch that show after writing. But here's a question from Ice Queen.
Ice Queen. Hi, Ice Queen.
What a nice name.
Lovely name.
Ice Queen Candy Toffee. Like, all her names are so sweet. Otherwise, she says, can you please explain how does a katabatic wind affect the valley?
Ice Queen, beautiful. I love it. How does a katabatic wind affect the ice? You've got me. So let's listen to this. Is it toffee? Is it candy? I love these things. I'm feeling so sweet right now, and I'm going to get that answer for Ice Queen. So Ice Queen, you're talking about katabatic winds, and what must you understand? How is it influencing the weather? We've said that the anabatic goes upslope. What happens with the katabatic? It's going downslope. So it's going to create a stronger layer of air at the surface of that valley. I'm going to go back to the diagram to show it to you. And look at this diagram. What's going to happen when katabatic airflow results? All the air is going to be concentrated. It's going to create an inversion layer. Remember that one, guys? And it's going to trap the air, especially the polluted air, along this valley. Great question, Ice Queen, and I hope you're going to be warmer for that and much sweeter for that answer. How are we doing, Abram?
Nice one. We're doing well.
Great. And guys, I know it's going to be a tight show because you've got so many questions, and I'm trying to get through as many as we can. So let's go back to our questions here and see what we can do to complete this particular section. Why would there be a high level of air pollution in the valley on a winter's morning? On a winter's morning, remember, temperatures are much lower and the air is trapped, and therefore, let's go to the answer. Air pollutants released by industries in the valley will be trapped, excellent, by the thermal belt or inversion layer. And simply put, guys, remember your winter temperatures result in more descending air trapping those pollutants in and around this valley. I hope you've understood this section, and I hope you've been able to understand that this particular concepts, especially in geomorphology, are brought together in the various different diagrams that you may get in your paper tomorrow. Let's look at the next question and know that this one is, again, drainage basins. Now, a lot of you have been asking about drainage basins, and I hope this particular question elicits some of these concepts that you've been battling with. Let's look at the question. Give 3 reasons why drainage basins are useful to people. General questions. Normally, I would start with define the term drainage basin. And if those of you that are listening, I want you to quickly define them for me. Write them down. And you? Yes, that's correct. A drainage basin is the total area drained by a river system and its tributaries. And because of this, we have various different landforms being shown. Your concentration of geomorphology, especially in grade 12, is how fluvial processes shape and form the Earth's surface. And in this example, we're asking you, give 3 reasons why drainage basins are useful to people. I'm going to go straight to the answer. Guys, I hope you're writing these things down. Remember, provide water for domestic use. Provide water for agricultural use, especially farming activities. Rivers can be used for recreational use, example, fishing and boating. Water transport, hydroelectric power. These are just but some of the answers, and we can go on. A drainage basin is any river system. And remember, it can be useful to man or woman in many ways. And you've got to understand that these kinds of questions are there for you to score the marks. Okay? I'm going to move on to the next question. And the next question is what I wanted to deal with for you, because these are the types of questions, and those of you that have been answering past year papers will know that river profiles is one of the key concepts that are being tested constantly. You have to understand how the river system moves from its source to its mouth at the ocean, and what formations result along its course. And let's look at it. Identify the type of profile labeled A. A is referring to the entire profile. Do you see that, guys? And here's your upper section or your source. Here's the mouth of the river. And it's divided into your upper, middle, and lower section. What type of profile? Look at the profile. It is a smooth, concave surface. Can you see the smoothness of this particular profile? What does it mean? Laminar flow. A flat surface is going to result in laminar flow. What is my answer? I'm giving you a second. Longitudinal profile? Correct. Longitudinal profile. A long or longitudinal profile. Okay? Let's go to the next question. What evidence suggests that A is a graded profile? Now, when we're talking to graded, we're talking to shape. Shape, concave. Shape, laminar flow. And I want you to look at the following. This particular profile exhibits a concave shape. And because of the concave shape, it becomes a longitudinal profile, guys. So my possible answer would be a concave shape. And the possible, it has a smooth concave profile. And that gives us the full 2 marks. And I'm going to move on to the next question. What forms the permanent base level of the river? Write that answer down. And I'm going for it. And you've got it, the sea. The sea is the ultimate base level or the base level of any river system. It is at 0 meters above sea level. So when you're talking about your permanent base level, you are talking about the sea level. Guys, I hope you're understanding that. And let's go to the next one. Describe the difference between the shape of the valley at B and the shape of the valley at C. Here we're talking to the cross profiles. The cross profiles is giving us an understanding of how does the river look from a front view. We've looked at the long profile, which is a side view. Remember, your side view is your longitudinal profile. But when you're looking at a river system from its front view, we are referring to the cross profile. What is the shape of that river system? Let's go back to the diagram. There's B, and there's C. Guys, look at the diagram. What are we seeing? We're seeing more depth, less width. And at C, we're seeing greater width, more depth. How wide is that river? How deep is that river? And especially in your upper section, your river has more depth and less width. So when we're talking to these concepts, you've got to be able to compare, because geography is a subject about comparisons and relationships. I hope you understand that when you're answering questions, you've got to be able to understand the differences in relationships and how they increase or decrease, or what we can say inversely or directly proportional, as well as comparisons and your ability to describe. So let's look at the possible answers for that particular one. And the answer is V-shaped for B and wide and open. Remember, your V-shaped is the depth, your wide and open is the width. More often than not, you find your V-shape is due to the down cutting, and your wide shape is generally due to the, yes, correct, the lower course of the river, where the river flows much slower. And now let's go to the next one. Give reasons for the difference in shape of River Valley B and River Valley C. Now these can be many, but what I'm going to say to you is remember the following: the velocity, the gradient. We need to talk about these concepts. The gradient is much steeper, which increases the velocity of the river. Therefore, the river undercuts or downcuts itself, and therefore the depth is much higher and the width is much wider. But what happens is, when you come to the lower course, Valley C, the river is reduced in velocity, less erosion, higher rates of deposition. And what does this mean? The width is greater and the depth is less. Let's look at the possible answers here. Vertical erosion or downcutting, lateral erosion, and deposition. And that brings us to what we would understand in geomorphology. Guys, I know it's coming to that point in time where you're asking yourself, what about this? What about that? How am I going to answer this? As Abraham has alluded to, and I know you're going to be at school and you can't be allowed to go out of school, especially during paper 1 and paper 2. But ask your school to switch on that TV so you can watch Mindset immediately after you write paper 1 and get as much as you can for paper 2. I'm not going to go too much, but I'm saying the following, guys. You've got 4 questions tomorrow. You've got 2 sections. 2 questions are in section A, 2 questions are in section B. You've got to answer any 3 questions. Look at yourself in the morning. Know what you know. Know that if I have studied hard enough for physical geography, I must answer question 1 and 2. Generally speaking, most of you are going to go for question 3 and 4. Great. Why? Because you are able to explain, you are able to understand and apply the concepts, especially in rural settlements as well as urban settlements. For people and places and people and their needs, I want you to go over those concepts and understand the different economic factors that contribute to how we develop this country. Further to that, I want you to look at your physical geography. Know your tropical cyclones and mid-latitude cyclones. They've been there. You've always been answering them, especially in your past papers, and you will be able to understand when we're talking to these concepts, we are talking to relationships as well as comparisons. Abraham, let's take a last question from you.
But while still on that one, here's a quick one from Pile. When choosing which questions to answer for the geography exam tomorrow, if I decide to leave out question 2, is it safe not to learn module 2?
It's not safe because, guys, you don't know which one has more. What you've got to know is that tropical cyclones could be in question 1 and mid-latitude cyclones could be in question 2. So you've got to be able to balance, and this is geography, and this is where you guys need to know that your studying needs to be structured in such a way that you cover all content. I remember Abraham saying you wanted some scope. Unfortunately, the scope is not going to help you because you need to have a good idea of all the concepts in geography. Abraham, anybody else?
Lastly, on essays, some mindsetters are asking, is it right for them to write in point forms or to write in full paragraphs?
Okay. Guys, let's say we've reached the end point and you need to write that essay as quick as possible. If you're writing in point form, don't give in a word. What I want you to do is write a full sentence. Write it as a phrase. Write it more than one word. If you have to bullet, try to avoid it. But if you have to bullet, make sure that you write a full sentence so that it looks like a paragraph. I don't want you to lose those marks, especially in the paragraph. Guys, good luck. I hope you're going to get the best marks possible, and all the best for tomorrow. Back to you, Abraham.
From us to you, we just want to say we believe in you, but never ever stop believing in yourself because we believe in you. And all the best, mindsetters. It's been a great show. Remember to still watch our shows and download your notes. From us to you, peace.
Let's go to the next question. Which major cyclone, low pressure, is driven by the westerly winds? Guys, immediately, major cyclone. You have only studied 2 cyclones in the secondary circulation model, and these are your tropical as well as your mid-latitude cyclones. These are the 2 that you should be focusing on. In this example, driven by the westerly winds. I'm going to give you a chance to answer that before I show you the answer. And the correct answer is mid-latitude cyclone. The mid-latitude cyclone is driven by the westerly winds. Remember your tropical cyclone, driven by the easterly winds. And these are the types of questions you're going to get to apply to this kind of diagram. Let's go to the next question. State the force, that deflects. And these words are the clues that are driving you towards deflection forces. You should already in your mind be thinking of pressure gradient, Coriolis, and geostrophic flow. And when these concepts come together, you apply it to the question. Force, deflection, southern hemisphere. Coriolis force. And let's have a look. Correct. The correct answer is Coriolis force. Remember the law, Ferrel's law. When in the southern hemisphere, the Coriolis force deflects air to the left, and in the northern hemisphere to the right. Good. I see you following well, and you're applying the concepts to the global air circulation model. Let's move further and look at the next question. What type of pressure is experienced in Area C? Let's look at the diagram. In Area C, immediately that's your 90-degree latitude. Remember, your equator is 0 degrees, your poles are 90 degrees. What type of pressure is experienced at the poles? It can only be either a high pressure or a low pressure. And remember the following, your pole is a high pressure area. So the correct answer there is high pressure. Are we seeing that the movements and planetary wind models are also being applied to the global air circulation model? Key concepts here, guys, to remember is the following. Your equatorial low pressure belt, your polar high pressure belt. And simple questions like this help you better understand the type of pressures experienced at these different latitudes. Let's go to the next question. The high cloud density in Area A is due to convergence or divergence of moist air. Let's go back to the diagram. Note the arrows are converging at this point, A. Are we seeing that? Arrows coming together, convergence. Arrows moving apart from each other, divergence. The question, note the following. The high cloud density in Area A is due to convergence. And that's your correct answer. Note the 2 marks. Let's move on. What I want you to concentrate on, especially with global air circulation, is the 3 cells. And note the following. The movement is localized in each one of those 3 cells. Know which cells are weak, which cells are strong. For example, your ferrule cell, which is between 30 and 60 degrees, is the weaker cell. Your Hadley cell, between 0 and 30, as well as your polar cell, between 60 and 90, are your high pressure cells and therefore much stronger. Let's look at the next question in climatology. The next one deals with synoptic weather maps. Remember, your synoptic weather maps is a graphic representation of a daily weather forecast. Okay? And when we're dealing with synoptic weather maps bring together and apply all the concepts of climatology. So you have to be able to understand each one of those concepts of mid-latitudes, tropicals, your 3 high-pressure systems on a synoptic map and be able to apply these theoretical concepts into one question. And in this particular question, we've headed it to the synoptic weather map, and you've got to be able to understand what's going on in this. Some advice, if you get a synoptic weather map in your exam paper, the first thing that you should do is outline South Africa. That'll give you a perspective of where you are in terms of the synoptic weather map, and it also gives you an even distribution between the east and the west. So let's look at South Africa on this map, and clearly this would help us better see the country in respect to all the formations that are around it. Immediately, I should be able to identify my isobars. There is a low pressure system that is developing on the east coast. Do you see that? That is obviously your tropical cyclone. What you can't see, I'm sure it's visible now, is tropical cyclone Funzo. And note it's on the east coast of South Africa. So let's just undo that. Okay, there we are. Let's look at the next question. Identify the pressure systems X and Y on the synoptic weather map as either a high pressure or a low pressure system. Let's look at the synoptic map. Locate X. Immediately we should see that X is located in this portion. There's South Africa, and what you should be seeing is it's on the west. So what does that mean? That means that this particular formation is your South Atlantic High, and therefore the correct answer is for X, South Atlantic High. Let's do Y before we reveal the answers. And Y, you'll note Y is located here, and that low pressure system there, and obviously The clues are given in this answer. Let's go back to the diagram.
Hello to you all, wonderful and awesome Mindsetters, Grade 12 Mindsetters. This is your best show for learning. Of course, it is Learn Extra Live with me, AB, and I'm joined today by Kamilin. I'm going to introduce him shortly because some of you, I know that you know him. It is geography today, and I just need to tell you about the competition that we're having, the awesome competition. I think everyone knows it by now. It is the Learn Extra Going the Distance Together, probably brought to you by Samsung in partnership with Mindset. All you need to do is to download your notes on the link that's going to be on the website, on Facebook, and go to www.mindset.co.za/learn/win. And that's where you could stand a chance of winning an awesome device like this one, a Galaxy Note 10.1. Now we're on leg number 6, which means there are only 3 more devices to give away. We've already given away other devices to lucky Mindsetters. Even today, you've seen on the page, we had Victoria Mukhala who came and fetched a Galaxy Tab 10.1, one like this one. So it is a cool device to have. On it, you can also access the Learning Hub. It has an S Pen, which is more like your real pen when you're writing. So many great features. Mindsetters, it is a must-have. If you don't have it, don't worry. Enter for the competition. I'll tell you more, and I might give you the race number. Otherwise, Mr. Kamlin, how are you?
Hi, Abram. Welcome, guys. Welcome to another exciting exam revision session. Today, we've got to get all our ducks in a row. Geography is just a few hours away, and I'm sure today's lesson is going to give you everything you need to get closer to that symbol that you need. Abram, are we ready?
We are ready, and from the page, I've been seeing a lot of Mindsetters that are doing geography specifically asking, are we going to have any scope? I think this is why they should watch the show, because this is the only scope that we're giving them.
Great, guys. The scope, you've got to know and be able to understand as much as you can, especially in your theory and map work. So we're going to start off with some questions taken from previous exam papers that is going to help you better understand and how to answer these questions. So let's get straight to it, and we're starting off with climatology, global air circulation. And as you can see, our focus today is as follows, and we're going to work through today all the paper 1 examinations. So if you have any questions on paper 2, please feel free to give them to Abram, but our focus today is going to be paper 1 theory paper and everything you need to know before you go. So let's go further and look at the questions that we have. If you look at the first one we've got, it's adapted from the February-March 2013 paper, and note the following: global pressure belts and winds. And we've got a diagram that shows you the entire globe as it is, with the arrows showing deflection. Remember, already you should be thinking, when air deflects, it moves across Coriolis force, correct? And this circulation is involving the 3 cells, the Hadley, the Ferrel, and the polar cell. So already in your minds, you should be thinking about these concepts and applying them to the diagram at large. Let's go to the first question and understand it. Name the pressure belt labeled A. When I go to my diagram, immediately A covers this area here. And no, it is not the ITCZ. It is a low pressure belt, because the question says, name the pressure belt labeled A. You could also include an answer like doldrums. Let's check the answer. And the answer is equatorial low pressure belt or doldrums. That is correct, and that gives you the 2 marks. Remember, when we are asked these kinds of questions, read carefully. It says describe, it says name. In this case, we were asked to identify and label. So in this case, the correct answer for A is your low pressure belt or doldrums.